Okay, 9.4 day 2, we're going to add period changes and vertical translations to our sine and cosine graphs. Okay, so this says for y equals a times the sine of bx and y equals a times the cosine of bx, what is the amplitude and the period? We did amplitude last time. The amplitude was the vertical stretch. So the amplitude is whatever's in the front. But because sometimes there's a reflection, we say it's the absolute value of a, which really just means that you're going to take the positive value because the negative indicates a stretch. It doesn't have anything to do with the amplitude. Okay, now the last time we graphed, the period was always 2 pi, and that's the standard period for the parent function of sine and cosine. If there is a number in the front, like 2x, 3x, 5x, it changes the period. So it's going to shrink the period. So the normal period is 2 pi. If there's a coefficient in front of your x, you divide by that coefficient. So it'd be 2 pi divided by b. Okay, we're going to practice finding them, and then we will practice graphing it. Okay, so for example 1, we're going to identify the amplitude and period of the given function. Okay, amplitude should be easy because we did it last time. Okay, amplitude, 5. Okay, normally the period is 2 pi, but if there is a number in front of your x, we change the period. So the period is going to be 2 pi divided by that number because it's the normal period divided by that factor. So 2 pi divided by 2 is pi. So the period of this new function is just pi. Okay, let's try the next one. Okay, b, f of x equals the sine of 5x. What's the amplitude? It's 1 because there's no stretch on it, and so that's the normal amplitude of sine. Okay, the period is not 2 pi because there's a coefficient on my x, so it's going to be 2 pi divided by the coefficient, which is 5. So 2 pi divided by 5 is 2 pi over 5. Okay, amplitude, 4. The period is not 2 pi because there's a coefficient. So 2 pi divided by the 2 pi. What's 2 pi divided by 2 pi? It's 1. Yeah, so the period's now 1. Okay, d, h of x equals negative 3/4 cosine of 6x. What is the amplitude? Yeah, the amplitude is 3/4. The negative indicates that there is a reflection over the x-axis. It doesn't have anything to do with the amplitude. The period is not 2 pi because there's a 6 in front of my x. So it's going to be 2 pi divided by 6, which is what? It's still a fraction, but can we simplify it? Yeah, let's divide it by 2, and we get 3. So the period is pi over 3. Okay, now let's try to graph something with a different period. So for example 2, we're going to identify the amplitude and period, just like we did in the previous example. Then we're going to label the scale of the x-axis in order to graph it with the new period. Okay, amplitude, 3. The period is 2 pi divided by this coefficient, which is 2. So the period is going to be pi. Okay, we're not going to freak out about the period yet. We're going to treat this like it's a normal sine graph, and then we're going to figure it out later. Now, it's not labeled on the x-axis because it's easier to change your scale than to change your actual points. Okay, I'm going to space this out. I remember from the unit circle that the important points are at the ends of the axes. So I need 4 good points for every period. Now, how you space it's kind of up to you. I'm going to space it so it's even so I can get to pi. So let's go with, I'm going to go with this, 2, 3, 4. I want 4 nice dots. Let me graph the 4 nice dots, and then we'll figure out the scale after. Okay, according to these 4 nice dots that I have equally spaced and could have spaced them differently, the sine is the y value, so it's going to go from 0 to 1 to 0. That should say -1 to -1. But it has an amplitude of 3, so it's going to go from 0 to 3 to 0 to -3 to 0. 1, 2, 3. Uh-oh, that looks funny, doesn't it? Hold on. When it looks funny, you stop and fix it. Okay, 0, 3, 0, -3, 0. And I could tell I messed it up because it was all squished. Okay, now I need to label the x-axis. Okay, this is the 1 period of the graph. According to my calculations, 1 period should take pi. So the point I'm going to label is that I did these 4 dots and I hit them all in pi. Okay, now my graph is graphed correctly. This is my first period. I hit all 4 of my dots and I finished the period in pi. So I've finished the pi. I already fixed it. Okay, I'm gonna graph a second period just to make it nice. It's gonna follow the same pattern. So however you space the first ones, keep spacing it. 1, 2, 3, 4. Now if this is pi, what's this? 2 pi. Okay, and I've labeled enough points. Let me follow the same pattern and graph the next period. So it went 0, up 3, 0, down 3, 0. So 0, up 3, 0, down 3, 0. And if you get off, you just stop and you go, wait, which point got off? Just like I did earlier. Okay, that's I graphed 2 periods of my graph, and then I'm going to put arrows at the ends because we know that this graph continues. Okay, let's try the next one. It's the same idea. We can graph the graph and we can adjust the period to make it work. Okay, what's the amplitude of this thing? It's 1 because there's no stretch. What's the period? It's 2 pi divided by 3, which is a fraction, but I promise it won't be that bad. Okay, on all these graphs, we care about those 4 dots. You don't need to draw this every time, but that's what I think every time. If I can hit those 4 dots, I will get the first period of my graph. So I'm gonna space this so that I have 4 nice spaces. I'm gonna space it like this, 3, 4. You could do each one on here. It's gonna make it miniature, or you could stretch it out and go 3 per or something like that. Okay, now I'm gonna graph the shape of it, and then I'm gonna adjust the period to make it work. Sine is the y coordinate, so I'm going 0, 1, 0, -1. And there is no stretch, so it's actually gonna follow that pattern. So 0, 1, 0, -1, 0. That's 1 period of sine. Okay, according to my calculations, 1 period of sine should end at 2 pi over 3, which means the point where I end is 2 pi over 3. So this is my first period of the graph, and I complete the period in 2 pi over 3. I'm going to continue the pattern because I want you to remember this is periodic and it keeps going. Same spacing, 1, 2, 3, 4. Same points, 0, 1, 0, -1, 0. Now, let's see if we can space this out. If this is 2 pi over 3, what's this? It's 4 pi over 3. Because I went 2 pi over 3, I went 2 pi over 3 more, now I'm 4 pi over 3. Let me sketch the second period of my graph because it makes it look better. Put some arrows, and then that's my graph. So changing the period is really just changing the scale. Okay, let's try cosine graph, and then we're going to do a vertical translation. So cosine, amplitude is 2. Period is 2 pi divided by 4 pi. Okay, then pi's cancel. 2/4. What does that simplify to? 1/2. Okay, the period's 1/2. We're not going to freak out because we know all we have to do is change our x-axis. Okay, this is cosine. Okay, you don't have to draw this circle, but these are the 4 points I think about every single time I graph something. And if I can get those 4 points right, I will get the graph. Okay, so I'm going to space it so I get 4 nice dots. 1, 2, 3, 4. Your spacing can be different, I promise. Okay, the amplitude's 2. What are we doing? Cosine. Cosine, I'm following the x-coordinate. So it starts 1, 0, -1, 0. But I don't start at 1 because it's vertically stretched by 2. So I'm going to start at 2 because it's cosine. So it goes 2, 0, -2, 0, and then back up to 2. I end where I start. Okay, that's 1 period. According to my calculations, 1 period should take 1/2, which means this point must be 1/2. Okay, I'm going to continue the pattern so I can get a second one. 1, 2, 3, 4. Okay, if I follow the pattern, what did we do? We did 2, 0, -2, 0, 2. 2, 0, -2, 0, 2. I'm following the path, and I ended at the point I thought it was going to end at. If this is 1/2, if I go 1/2 more, I'm at 2 halves. What's 2 halves? 1. So the second period ends at 1. Okay, I'm going to sketch my graph. Remember, these are curving, and it should look like it's going back down to the left. This is my first period, and then my second period. Okay, and make it look like it goes back down because it's not going to go higher than 2. Okay, example 3. Identify the amplitude and period of the function with a vertical translation. We're going to label the scale on the x-axis of the graph, okay? So we're going to add a vertical translation. Okay, let's just look at this. F of x equals sine of x plus 2. What's the vertical translation? It's right here. This is telling me it's going up 2. Okay, let's look at the amplitude. The amplitude's 1 because there's nothing in front, so it's normal. What's my period? I still just look at the x. The x is just normal, so it's a normal period. The period's 2 pi. Okay, now, since we're going up 2, I like to move what they call the midline up 2. So normally my graph goes like this around the x-axis. I'm going to go up 2 and move my midline. So I'm going to go up 2, and this is called a midline. I'm making it dashed. It's not my graph, but it's going to help me graph my graph. Okay, now I'm going to graph everything around this graph instead of the next graph. Okay, I'm going to graph it, then I'm going to fix my period. Okay, just like always, there's the 4 dots on my circle. And no, you don't have to draw this every time, but I think about this in my brain every time I graph it. Okay, amplitude's 1. Sine is the y-coordinate, so this should go 0, 1, 0, -1. Okay, let me space it out. 1, 2, 3, 4. Okay, I should go 0, 1, 0, -1. Instead of starting from here, I'm going to start from my midline, so that way I've already moved up 2. So from my midline, 0, 1, 0, -1, and then back to 0. Okay, let's look at this. Okay, this is the graph of sine, but it got moved up 2, and I moved all the dots up 2, and that's my first period. Okay, it told me the period is 2 pi, which means this point must be 2 pi. Let's continue at one more period just so it looks nicer. Okay, I did this, up 1, this, down 1, back to 0, up 1. Now let me space it first. 1, 2, 3, 4. Ooh, if that's 2 pi, what's this? 4 pi? Okay. Okay, up, back to 0, down, back to 0. I ended where I thought I was going to end, so I feel good about it. Okay, this is going to be my sketch of sine. Okay, and it looks like the sine graph, and it looks like it got moved up 2. Let's try the next one. Okay, B, g of x equals 2 cosine x minus 3. Where's the vertical translation? Right here. It goes down 3. Okay, I'm going to move the midline down 3 just because it makes it easier to graph. It's this dashed line. The dashed line does not have to be there, but if you have it there, you are much less likely to make a mistake because it will look funny. Okay, amplitude is 2. The period, I look at the x. The x is just normal x, so the period is just 2 pi like normal. Okay, I still want to hit those 4 dots. And hopefully you're starting to memorize it, actually. Okay, let's see. I'm going to space it by 4s. 1, 2, 3, 4, because I want to hit my 4 corners. Okay, what are we doing? We're doing cosine, amplitude 2. So cosine, I start positive, 0, negative, 0. I don't start at 1 though because the amplitude's 2. Okay, and I'm going to go from my midline. This is my midline. Okay, so from my midline, I'm going to go to 2. Okay, then I hit 0, -2, 0, and I go back up to where I started from. Okay, so it's the 2 cosine x, but it got moved down 3. Okay, I'm going to continue it for another period. 2, 3, 4. Okay, so where was I? I was up 2. I should be going back down to 0, down to 0, back up. I ended where I thought I was going to end, so that's a good sign. Let me label my period. The first period should have ended at 2 pi, so this must be 2 pi, which means this must be 4 pi. And then let me go ahead and sketch my graph. It's cosine. We make it curved, and we try not to make it go above the amplitude because that would be a lie about our graph. Okay, so it looks like 2 cosine x. It looks like it got moved down 3. Okay, last one. We're going to mess with all this stuff. Okay, this has a vertical translation. What does it do? It goes up 4. Okay, I'm going to move the midline up 4. Again, you don't need this line, but if you draw the line, you are more likely to tell when your graph looks funny. Okay, cosine. Let me hit my 4 dots. Okay, what is my amplitude? Amplitude is 1. My period. Oh, there's a period change because this is a 2x. So it's going to be 2 pi divided by 2 which means my period is now pi. And I can go ahead and label that. The fourth dot should be pi. Okay, let me draw my pattern. Can we do it without the circle? What is the cosine of 0? 0 is 1, 0. Cosine's the x-coordinates. So it starts at 1 from my midline. So from my midline, I'm going to go 1. Then I should hit 0. Negative 1, 0, back to 1 at pi, which is what I was thinking, so it looks right. Let's go one more period. Okay, that was 1, back to 0, down, 0, up. And I didn't mark it. 1, 2, 3, 4. What should this point be? 2 pi. Okay, let me sketch my graph in. Okay, and it should look like cosine. Okay, it's the cosine graph. This is the cosine graph. It got moved up 4. And the period got changed to pi, so when I finished my 1 cycle, it ended right at the pi.